Hello and welcome to Module 2, Systems and Process Models, Concepts, Stakeholders, Problem Statement, and Requirements. In this module, we will just demonstrate operational and maintenance requirements development process. Going back to the Blanchard and Fabricki diagram on figure 2.4, we are still in the conceptual design component under design considerations. Here we'll talk about the more detailed elements specifically within operational requirements and maintenance requirements. These two types will be discussed in the next coming slides and are two of the most critical ones within the system requirements analysis. First, let's talk about operational requirements. The first question to be asked is this mission profile or scenario. How critical is the particular requirement? Is it primary or is it secondary? A primary requirement would be table stakes and requirement for success, such as mission accomplishment, whereas secondary might be performance or how they do it, increase market share, performance and related to physical parameters. So what are the basic operating characteristics or functions? How big does it have to be? How fast? So in an airplane, how many passengers does it need to haul? How large does it have to be? How wide does it have to be? How heavy? All those sorts of things. Operational deployment and distribution. Number of sites or geographical distribution. Is this a system that is used just within a confines of a particular state? Is it multiple states? Is it across the world? Is it in the northern part of the country? Is it in a very warm climate? All those sorts of things. Operational life cycle. How long is the system expected to last? Utilization requirements. What is the anticipated usage? How will the end user use the system? What will be the capacity? How frequently will they be using it? If it's a computer, is it something that they will use every single day? Is it a smartphone? Is it something they're going to be using every hour of the day or in some cases every minute of the day? Or is it a combine harvester or some other piece of farm equipment that might only be used once a year but needs to be ready and functional when it is required? Effectiveness requirements. What is the cost versus the system effectiveness? Availability, reliability, and maintenance. So how far can it go between downtime? How long can it continue to run? What is the mean time between failures? How reliable is that system? And then environmental factors. What does it need to be able to hold up to? Are there external requirements such as time or temperature, environment, rain, weather, sorts of things that it needs to handle? Is it shock or vibration? Is there a requirement that it must be a very stable footing because it's very heavy and that sort of thing? The operational requirements essentially have to answer four main questions: the what, when, where, and how. So first of all, the what, that is what the requirement is all about, is what functions will the system perform? What does it have to be able to do? What does it have to be able to demonstrate in order for that system to be successful? When will the system be required to perform? How long? What duration? Will it be many short bursts of time? Will it be one long time? Will it be a continuous cycle? Where will the system be used? This is where geography and environment play into account. And then how? Will the system accomplish its objectives? Will it meet the requirements? How is it going to do that? All these questions need to be asked up front, and establishing these operational requirements forms the very basis for the entire design system. These types of questions need to be answered in the very early stages of the system development process. From the operational requirements, the next piece is the maintenance and support concepts. So there are 6 main requirements for maintenance and support. First of all, repair policies. At what point in time do you repair versus replace something all entirely? And that's what repair policy comes into play. For a car, an example, there might be some components that if they go bad, you will simply replace them. If there's other ones that go bad, you will clearly go and just purchase a whole new vehicle. And then, of course, there's the other factors, such as how long does the car have left? If a transmission goes bad and a car has 10,000 miles on it, you would probably repair them or replace the component. If it's got 180,000 miles, you may not want to spend that type of money for it, and you would instead invest in a whole new vehicle. Organizational responsibilities includes maintenance responsibilities by potentially the customer or a third party. So again, staying with the car example, some things might be done by the consumer, some might be done by the mechanic or the shop. For example, I might go and change my own oil or fill my own gas or put in my own washer fluid. However, if it comes to replacing an engine component or doing body work on it, I would take that to a shop and train professional. Maintenance support elements, repairs and repair parts. Are there highly specialized tools involved? Is there a highly complicated specific training required that you need to have a particular skill set involved or a trained technician? Is there a safety or handling and disposal guidelines that need to be required? Effectiveness requirements. How can you get spare parts and how quickly could you get them? Do you have a distribution center that you can get spare parts immediately? Is this something that you can just go and order online and have it in 2 days? Or is it a case of you're working for NASA and you're sending a space shuttle into orbit and you can't get spare parts up there and you have to find another alternative? Environment. Environmental conditions supporting this. Again, sticking with NASA, if you have a space shuttle up there and you have to do operations outside in the space, the cold vacuum of space definitely factors into the ability to do maintenance and support. And then levels of maintenance. This is divisional functions of maintenance. So what is to be done and by whom? And we'll talk about the levels of maintenance in the next couple slides. This slide explains divisional function of maintenance by organization, intermediate, and then depot or producer. Organization level will be on the local level or typically your lower skilled requirements. Intermediate maintenance would be an intermediate skilled, potentially a trained technician, for example. And then a depot would be the highly skilled producer or typically a factory or fixed facilities designed specifically for that, for more of the precision type of work. Using a car as an example again, the organizational maintenance might be done on the local level, might be those small oil changes, even a tire change or something like that. Intermediate maintenance might be something that you would take to a technician and somebody who does changing an alternator, replacing spark plugs, and some more of the slightly more complicated but not too intensive maintenance. And then if you're going to go in for a complete overhaul or a massive rebuild or something on a larger scale, that might be the depot or more highly skilled type of maintenance requirement. This chart here looks at those 3 levels of maintenance that we just discussed as stratified by the where, who, how, and what considerations. So organizational maintenance, intermediate maintenance, and the depot maintenance, as we just discussed, run across the top in your criteria. And those particular questions that you would ask, the done where, done by whom, on whose equipment, and the type of work accomplished, that runs down the vertical axis. This graph in here explains who is responsible for what elements and how the maintenance is to be performed. This is a very simple and straightforward tool, but yet is very powerful in clearly delineating responsibilities and making sure that there are no gaps in capabilities. For example, if you look at the lower levels of organizational maintenance and you say, this is where it needs to be done, then you have to ask yourself some of those specific questions, such as how can that be done? Do they have the tooling involved? Do they have the skills involved? And to make sure that you have all your bases covered in there. This is a good tool to use very early on in the requirements process.